Today we're going to be solving quadratic equations using the zero factor property. You should have this handout that was given to you Monday night. You'll notice that step one is to write the equation in standard form. That is, all the terms on one side of the equality, the equation sign, in descending order. That means x squared, then the x, then the number, and 0 on the other side. Then you factor completely, and then you go on from there. So we're going to look at the first problem, which is on page 389, and it's problem number 11. We are fortunate enough in this problem that it's already been factored for us. So all I have to do is take each factor and set it equal to 0. We're using this idea right here, because if two numbers multiplied together equals 0, then one of them has to be 0. That's what this says. There's no way you can multiply two numbers and get 0 for the answer unless one of the numbers is 0. So in this case, we don't know which one is 0, so we look at the possibility that it could be either one, and then you solve each equation. So I'm subtracting 5 from both sides on this one, and I'm adding 2 to both sides on this one. So my solution set is -5 and +2. Now, number 4 on our handout says we should solve the resulting equation, which we did. And then it says to check the result in the original. That means let x be -5 and make sure that the product would be 0, and let x be 2 and make sure that the product would be 0, which is true in this case. All right, so next we're moving to number 15. Again, we were fortunate enough that this one was already factored for us. So all I have to do is to take each factor and set it equal to 0. And then I'm going to solve the resulting equation. So in this case, I need to subtract 1 from both sides. And then I divide by 2. And I get -1/2. On this one, I add 1. And then I divide by 6. So this one, the solution set is -1/2 and +1/6. All right, next I'm going down to number 17. Again, it's factored. It's factored differently, but it's still factored. I have two factors. They are t and 6t plus 5. So I set each one equal to 0. This one's already solved. There's nothing to do there. This one, I need to subtract 5 and then divide by 6. So for this problem, my solution set is 0 and -5/6. Okay, so now I'm moving to number 21, and I set each factor equal to 0. And I add 6 in both cases. Well, my answers are the same. Well, when you're given the answers, if it's the same, there's no need to say it twice. So you just say the solution set is 6, and you're through. Next, we're going to look at number 23, and you'll see that this one is not yet factored. So the first thing I have to do is to factor it. Since this coefficient's a 1, all I have to do is find numbers that I can multiply to get 2, +2, and add to get +3, which is a +1 and a +2. Because 1 times 2 is 2, and 1 plus 2 is 3. Now that I have it factored, I set each factor equal to 0 like we did in the previous problems. In this case, I subtract 1 In this case, I subtract 2, and my solution set is -1, -2. Now I'm going to move to number 27. Remember on our paper of our instructions, number 1 is to write the equation in standard form. That means one side is 0. Well, this one's not in standard form. So sorry, I don't mean to make you jump. So the first thing I have to do is to get one side 0. So to accomplish that, I'm going to add the 5x to this side, and I'm going to subtract the 24. See, the 5x was negative, so I added it to move it across the equal sign, and the 24 was positive, so I subtracted it to move it across the equal sign. And I did it in that order so that it's in standard form. X squared, then x, then the number. Again, this leading coefficient is 1, so all I need are two numbers that I can multiply to get -24 and add to get a +5, which is a +8 and a -3. So that's the same factoring like we've been doing. Now set each one equal to 0. Whoops, that's an 8. Subtract 8 from both sides. Add 3 to both sides. So if the equation's not in standard form with one side being 0, that's the first step. Then you factor, then you set each factor equal to 0. Our next problem is number 31.